So we consulted our magic 8-ball, and the answer came up that the future is in the cloud. Calling xGDBvm iPlant, which is a way to manage, view, and also re-annotate genomes, large and small, in the cloud using iPlant's resources. There are a number of resources at iPlant that we wanted to make use of, and the first is the Atmosphere VM platform, which is becoming more robust on a daily basis. In fact, it's going to be a very powerful system for checking out and using virtual machines for a wide variety of purposes, including the one that we're interested in. And another important feature is the iPlant data store, and another system of data storage called the EBS, or Elastic Block Storage Device, both of which are available at iPlant and can be used in the case of the data store for very rapid upload of data and availability to virtual machines on the Atmosphere platform, as well as portable data storage in the form of this Elastic Block Storage volume that allows you to move data from one VM to the other, move it back to the data store, and so forth. So these are very useful to us as well. And finally, the other linchpin is the availability of the power of the Texas Advanced Computing Center's high-performance clusters, including Stampede and Lone Star, which are also accessible to the data store, so data can be moved back and forth readily between those two, and therefore can be moved in and out of a virtual machine as well. And then finally, the glue that holds this all together is the Foundation API, which has been reborn as the Agave API for controlling various processes, including, for example, user authentication and validation and job management, reporting the status of high-performance jobs. We're going to load an example data set. We have a number of example data sets with toy data to exemplify the different features. We're going to use remote computing in this example, and you can see that the remote resources have been selected for both GeneSeeker and Genome Threader. And now everything else is filled out, so we're going to save that example. Then we go to data process mode, or options mode, and our only option now is to create a database, so we click that, confirm, and now the pipeline is initiated. And this is all running at iPlant on our VM. And you can see that our status is locked. We can look at the latest step in the process. We can also look into the log file to get a real-time picture of what's going on in the pipeline process. Maybe too much information for a lot of people. We can also check on the remote jobs. Since this is a toy database, the remote jobs have already started. And we're talking to the TAC computer through the APIs now to look at the status, and when the data comes back, we can count the outputs for both GeneSeeker and Genome Threader. This is just, if you're interested, you don't have to do any of this. It happens automatically. Now we can go back to our configuration file to see what's going on. We're now doing gene prediction via CPGAT on the second of 2 segments. And skipping ahead to done, we're now in current status. And under the drop-down, we can see a new GDB has showed up as a menu item. Now we're on the home page, and we're looking at an outlay of the tracks that we've splice-aligned, protein and EST, as well as pre-computed and CPGAT computed gene models. So the conclusions are that cloud computing can be valuable for bringing the researcher closer to high-performance bioinformatic processes, and also that iPlant has the people and the systems to make that happen.